Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest. Apply operations on array to maximize sum of squares. The problem involves bitwise operations. So if you face difficulty in solving bitwise operator problem in general, you can watch this video, and there was a similar problem involving bitwise operator in the last week's contest as well. So after watching that video, you can try that problem as a follow-up and practice problem. With that, let's get started. The problem states that you are given a zero indexed array nums and a positive integer k. You can do the following number of operations any number of times. You choose any two distinct indices I and j and simultaneously update the value of nums of I to nums of I and nums of j, and nums of j to nums of I or nums of j. You have to choose k elements from the final array and calculate the sum of their squares. Now we need to return the maximum sum of squares that we can achieve. So we can apply this operation as many times as we want, and after we have the final array, we'll have to choose any k elements from that final array, and the sum of squares of those k elements should be maximum possible. So let's take an example. Let's say nums is 2658 and k is 2. So we can apply the operation on this array any number of times, and after we are satisfied with the operations we are applying, we have to choose two elements such that the sum of square of those two elements should be maximum possible. So what they have done is they have choose I equals to 0 and j equals to 3 in the beginning, and they applied the operation. So after applying the operation, nums of I would become nums of I and nums of j, and nums of j would become nums of j or nums of I. So if you do AND of 2 and 8, you will get 0. If you do OR of 2 and 8, you will get 10. So that's what the array is now, 2, 0, 6, 5, 10, right? Now after that, they have chosen I equals to 2 and j equals to 3. So again, if you apply the operation on I equals to 2 and j equals to 3, this will become 5 and 10, which is 0, and this will become 5 or 10, which is 15. So after applying the operation, it will become 0, 6, 0, 15. Now they stopped the operation here, and they choose 6 and 15. Notice that we have to choose two elements. So they choose 6 and 15, and the sum of square is 261, which is the maximum possible sum of square that you can achieve by applying operation in any order as many times as you want, and hence the answer here is 261. So hope the problem statement is clear. Now how to solve this? As always, instead of solving this problem directly, let's try to simplify the problem and let's solve that problem first. So let's assume that the given array can just contain one bit. Basically every number can either be 0 or 1, and let's try to solve the exact same problem on this reduced version of the array, because if you're not able to solve the problem with just one bit, solving it with more number of bits is even harder, right? So I would encourage you to pause and try to solve this problem by yourself. It is very easy. So here k is 5, so basically we have to select 5 elements at the end and find the sum of their squares, right? So sum of square, like the number can either be 1 or 0, right? So we want to maximize the number of ones that we have. So k is 5, right? So we have to select 5 elements. We already have 4 ones, right? So the sum of squares would become 4 if you just select these 4 and one of these zeros, right? If we want to maximize this further, what we want is we want to introduce one more one, basically either of these three zeros. If we can convert any of them to 1, then the sum would become even greater. So let's see if we can do that. So we have this operation only. With this operation, can you convert or can you introduce one new one in the array? Let's see. So if let's say this is I, right, and this is j, basically I can be either 0 or 1 and j can either be 0 or 1, right? So for now we are taking I as 1 and j as 0. If you do this operation, I would become 1 and 0, which will become 0, right? And j will become 1 or 0, which is 1. So basically here no new one is introduced. Instead the number just got swapped, right? So with this operation we are not able to introduce new one. So this is of no use for us. So let's see this now, right? So I is 0 and j is 1. So again, if you apply the operation, this will become, I will become 0 and 1, which is 0, and j will become 0 or 1, which is 1. Basically whatever was there initially, the same thing comes after applying the operation. So again, this operation is also of no use. Basically we are not able to produce one new one. Now if everything is 0, basically if I and j both are 0, we know that it will not change anything. The final output will be 0. The last thing is I1 and j1. If you do this, finally you will get 1 and 1, which is 1, 1 or 1, which is 1. Basically it stays as it is. So with any operation we are not able to introduce any extra 1 in this array. So basically the number of the output for this particular array would be simply the number of ones, or minimum of number of ones comma k is the output, right? Basically if we have to choose k as 3, or if you have to choose 3 numbers, we will just select the 3 with the value 1. If you have to select more than 4, basically 5, we'll just select the one which have value 1, and rest we are sure that it will be 0. So the maximum output would simply be min of k comma number of ones, right? So hope this point is clear. Now let's try to solve the exact same problem on 2 bits, and here the problem becomes a bit interesting, right? Why? Let's say this is I and this is j, right? And if you do this, what will happen? One I and j, if you do I and j, so this is basically the 0th bit, this is basically the first bit, right? So if you do I and j, this will become 0 and 1. The first bit would be 0, right? Second bit 1 and 0, again 0. So the value of I would change from 1 to 0. What will be the value for j? 0 or 1, which is 1, and then 1 or 0, which is again 1. So the value of j would be 3, 1 1, right? And value of I would be 0. So notice this is completely changed from the original values. Original values was 0 1 and 1 0, basically 2 and 1. But here the value becomes 0 and 3. So from previously, in the previous 1 bit operation, this kind of situation was never happening. The actual number stays as it is, but here the numbers are now changing itself. From 2 comma 1 we are getting 0 comma 3, right? So now the problem arises, okay, is this operation of ij worth or not? Basically, how can we actually determine whether applying this operation will give us better result or worse result, right? So let's take a generic example and let's try to answer this specific question, whether applying an operation can give us a better result or a worse result. So let's say these are the two numbers. Now this time I have represented this is like 2 power 0, right? And this is 2 power 1, 2 power 2, and so on and so forth. So here it is horizontal, rather it was vertical here. So if you apply the operation, this is I now and this is j, right? Now if you apply the operation on this, what would I become? I and j. So basically 1 and 1 1, 0 and 1 0, 0 1 and 0 0, 0 and 1 0, 0 and 1 0. So I would be translated to this, right? And j would be translated to this. Basically j will contain all the bits that are either set in I or set in j, right? So what's happening? Let's say they have some common bit. So the value of that common bit is, let's say, x, right? Now we have something extra than x here, right? So basically in this case x is 1000016, right? And we can represent I as x plus a, right, where a is 4 here. So basically if you do the decimal representation, it will become 20 only, right? So x is 16, a is 4. Similarly you can represent j as x plus b, right, where x is again 16 and j is this particular bit, which is 8 plus 2 10 plus 1 11. So 16 plus 11, which is 27, right? So this is how you can represent I and j. Now what you want to answer is, after this after you apply the operation, this will be converted to x and x plus a plus b, right? Because the first one would contain only the one which is common, right? So common part is x, and second one would contain all the bits which are either set in x, either set in I or set in j. So it will contain the common piece for sure, and all the other bits that were set in j and not set in I, and vice versa. So basically it will contain both a and b. So from x plus a comma x plus b, you are converting to x comma x plus a plus b. Now what you need to answer? You need to answer that whether this operation is worth or not. So what will happen? Finally this will happen, right? You want to take the sum of squares. So sum of square previously was x plus a square plus x plus b square. Now sum of square after the operation would become x plus a plus b square plus x square. Now which of these two is actually greater? So this is straightforward 11-12 class mathematics. If you look at it, you can simply answer that this one will always be greater no matter what the value of x, a and b are. So this will either be greater than equal to this value, right? So because we can mathematically prove that after applying the operation, the sum of square will always be at least as good as the previous sum of squares, we can actually conclude that no matter what, if we keep on applying the operation, we will not make the things worse. Basically whatever sum of squares we would be getting previously, we will at least get the same sum of square after this operation is applied, right? So I would encourage you to rewind and watch the previous 2 minutes if this particular concept is not clear. But for now, the conclusion that we are moving ahead with is, we will always apply the operation, because applying the operation will not make things worse, right? So with that, let's try to apply the operation. So in this particular case, we will apply the operation and we will apply as much time as we want, because we know applying the operation will not make anything worse. So if we apply the operation between this I and this j, let's say, right? So if we apply the operation, what will happen is, this will become 0 1 and this will become 1 and 1, right? Now let's apply the operation here as well, right? Basically what I'm trying to do is, we know that if we do OR, we will be getting as much set bits as we can. So what I'm trying to do here is, I will be doing OR all the way to the right, because if we do OR all the way to the right, at the very end I will be getting the maximum number, because at the end we will be ORing every bit. So if there is at least one number which have this particular bit set, at the end that bit will be set. So let's do this operation. So if you do this operation on this I and this j, you will get 0 1 and 1 1, right, after the operation is complete. Now if you apply the operation as this I and this j, you will again get 1 1 here, and this will become 0, right? So this is 1 0, this is 1 and 1, right? Now if you apply again with this, what you will get, the same thing. Basically this particular this particular thing would become 0 and this will become 1, right? And if you keep on doing this, at the end you will be getting 1 and 1 here, because at least one bit is set in both the case, right? So let's just take one particular example. This will make things much more clear. So this is how this algorithm will proceed. Basically we want at the end the maximum number of ones that we can. So what we will do, we will simply keep on applying the operation until the end. So first this is I, this is j, then this is I, this is j, then this is I, this is j, and so on and so forth. So if you keep on applying the operation, if you can see, if you apply with this I and this j, this will become 0 1, so this has become 0 1, and this will become 1 and 1. But 1 and 1, if you apply the operation here, this will become 1 and 0 after applying the operation. So this is 1 and 0, and this will become 1 and 1, right? So if you apply the operation here, again this will become 1 and 1, and this will become 1 and 0. So that's what it is, 1 and 0. Now 1 and 1 will proceed further, and if you apply the operation here, you will again get the same. So after you applied the operation all the way to the right, you are sure that at the right I will be getting the maximum number, and this is my first value that I will include in the sum of squares, because this is the maximum possible number that I have, that I can make. Now let's remove this altogether. Let's say this number, this index is something we have fixed. Now we will not change this. Now from this array we have to now select k minus 1 number. So the strategy would be again same, right? Because we know that applying the operation will not make things worse, I will simply keep on applying the operation all the way to the right, so that this particular space will have the maximum number possible, and I will take that in my sum, right? So that's what we have done. We will keep on applying the operation until here now. So if you apply the operation here, this will become 0 0, right? And this will become 1 and 1. Now if you apply the operation here, what will happen? This will become 1 and 0, and this will become 1 and 1, right? So 1 and 0 is here, and 1 and 1 will propagate further. So if you apply the operation here, what will happen? Again this will become 1 and 0, and this will become 1 and 1. So 1 and 0 is here, and 1 and 1 is propagated further. Now if you apply the operation 1 and 1 and 1 and 1, this both will be remain same. So this is 1 and 1 again. Now finally if you apply the operation here, you will get 0 0 here and 1 1 here, right? So that's what we have, 0 0 here and 1 1 here. Now this is the maximum number that we can get at the 5th position. So now I will fix this particular thing. Now from the remaining, I need to select k minus 2 numbers. So again I will apply the same strategy. Because I know that applying the operation will not make things worse, I will simply keep applying the operation until the end, so that I can get the maximum possible number at the end. So this is the way I will proceed, and finally we will stop at here, because after this point everything after this space is 0, right? So if k is 1, we will simply take this number. If k is 2, we will take these 2 numbers. If k is 3, we will take these 3 numbers. If k is 4, we will take this 4. If k is 5, we will take this 5, and 6 7 doesn't matter, because after that everything is 0, right? So this is exactly how our algorithm will proceed. So what would be the pseudocode look like? Pseudocode would simply look like this. So we will apply the operation k number of times. In each operation, what we want the last number to be maximum possible, right? So, and because we know that applying the operation will not make anything worse, we will simply apply the operation all the way starting from 0 to the n minus I minus 1th number, basically the number which we want to fix, right, in this particular iteration. So what we will do, we will simply apply the operation on j and j plus 1. So this j would become array of j and array of j plus 1, and this j plus 1 would become array of j or array of j plus 1, right? Now after you have applied this operation k number of times, you will simply select the last k numbers and sum up their squares, and that will be the maximum possible answer that you can have, right? So what will be the time complexity of this entire solution? The time complexity would simply be order n square, because k can be up to n. So this loop will take order n and this will take order n. So this is order n square. So we are able to solve the problem in order n square, but or order n into k for that matter, but n and k both in this case are 10 to the power 5. So this n into k solution or order n square solution will not pass. So we have to optimize this. Now I would strongly encourage you to pause and try to optimize this order nk solution by yourself. So hope you thought about it. Now let's see how we will optimize this. So let's look at this closely. What's happening here? We take, or we are getting maximum value here. Now what will be the maximum value? Maximum value would be 1 at every bit, right? That is the maximum value. Now can you get 1 is the question at this particular bit. So which factor does it depend on whether you can get one here or not? Basically, if there is at least one in the prefix, we are sure that we'll be getting 1 here. We'll be getting 1 at this particular bit. Similarly, for this particular bit, what is the criteria? Criteria is simply if there is at least one in this particular prefix, I will be getting a 1 here, right? So with this particular observation, we can simply say the value of 6, a value at the 6th index would be 1 and 1, because we know that there is at least 1 in this particular prefix, and there is at least 1 in this particular prefix as well. So we now get the value at position 6, right? But with this, everything else has changed drastically. Basically, previously it was 1 it now becomes 0 it was 0 it become 1 everything has changed, right? Now we don't want to compute everything here. That's the only way you can avoid order order n iteration for every element that you are trying to do or trying to save. So we don't want to actually update all of these. So how can you avoid updating all of this? But you also want what will be the value at 5th index, and the value at 5th index will also again depend on, is there any 1 in the prefix or not. If there is 1 in the prefix, the value here would be 1 at the particular bit, otherwise it would be 0, right? So without actually figuring out the exact configuration in the prefix, you want to answer whether there is a 1 in the prefix or not, right? So how to solve that? So this can be solved with one observation that we have made when we were solving for 1 bit. Basically, we saw that the number of ones that exists in this particular array is something you can't change at the end, because when you do and if there was at least 1 that will become 0, but in the second part it will become 1, right? If you do and if you apply the operation on 0 and 0, it will become 0 and 0 for sure. But if you apply the operation on 1 and 1, you will be getting 1 and 1 only, right? So number of ones that exist will not change ever after applying the operation. So that's, with that strategy, can't you answer the question if there is a 1 in the prefix or not? With this strategy, basically we know that there is 1 2 3 4 5, there are 5 ones in total at 0th position. So with 5 ones, I am sure that I can get 1 1 all the way up to second position, because there are 5 ones, and if you get 1 1 here, there will be 4 ones remaining in this particular prefix, so this will automatically become 1. Similarly, if you fix these two position, basically you have taken 2 ones, so there will still be 3 ones remaining in this prefix somewhere, right? Where it will be, I'm not sure, and I don't care as well. I just want to know whether there is a 1 in the prefix or not, and we know that there will be at least 3 ones. So if there is a 1 in the prefix, I know that there will be 1 at 4th index as well, and similarly we'll get the 1 at 2 and 3 index as well. So in the same fashion, you can apply the same trick for the second bit as well. So second bit has 2 ones, right? In total, sorry, 3 ones in total. So you will be getting 3 ones at the end in the array, and you want the numbers to be maximum, so you will be getting 1 at 4th, 5th and 6th position, right? Now some of you might be thinking that, okay, how can you actually decouple the 0th index and the first index? Because we know that for a single index, the number of ones will not change. But how can we decouple the 0th and the first index? The answer lies in the fact that we are not decoupling. We are saying that the number of ones will be same at each position. So, and we are also saying that we will be doing OR all the way up to the last index, right? So if you do OR all the way up to last index, wherever the 1 will be, we are sure that we can get the 1, then get that particular 1 to this particular index. So that's why we are not actually decoupling the first and second index, if you see in action, because at the end what you will be doing, you will be doing OR of every particular numbers here and getting the value at the 5th position. So that's the algorithm in which you will actually save calculating all the values for every iteration. So what we will do, we'll simply calculate the number of ones at each position or at each bit. So in this particular case, the number of ones at the 0th bit is 5, number of ones at the first bit is 3. Now the final array we can simply build very efficiently. We can simply fill the last 5 as 1, last 3 as 1 in this first index, and so on and so forth. And finally you will simply take this you will simply take the number starting from the right, because the rightmost number is the greatest. So if k is 1, you will take this number. If k is 2, you will take this 2. If k is 3, you will take this 3, and so on and so forth. So what is the time complexity now? You are simply iterating over every bit and trying to figure out how many number of ones are there. So how many bits can be there? At most 30, right? Because the number is 10 to the power 9. So 30 bits are there. For each bit, you will be calculating the number of count of bits. So 30 into n. And after you calculate the count, you will be filling up this particular matrix, right? So this particular matrix again will be of 30 across n size, and you know how to fill it in order 30 into n time itself. So this will multiply by 2. So this is the overall time complexity, which is basically n into number of bits, and which will pass the given time constraint as well. So if you have watched till this point, I would strongly encourage you to pause and try to code this entire thing by yourself, because the coding piece is very straightforward. You just need to count the number of bits and then prepare the array at the end. So that is finally the solution. Next we're looking at the code. So I hope you have tried this at least once by yourself. So the code is straightforward. We'll simply count the number of bits here. So if you count the number of bits, what you will do, you will simply go over each bit and see if that particular bit is set in the jth element or not. If it is set, you will simply increment the count. Now after you got the count for every particular bit, what we have to do, we have to fill this particular matrix. So instead of building the matrix, what I am doing is I am iterating from the right. So I am saying that I need to fill k values at the end. So the largest value, what will be the largest value, is something I'm trying to find out here. So if you see this particular value, what will be the value at this particular index? The value would simply be 1 at first position if there is a 1 in the prefix, 1 at second position if there is a 1 in the prefix. So that's what I have done. If there is a 1 in the prefix left, if there is no 1 in the prefix left, we'll simply continue. If there is a 1 in the prefix left, I know that this particular bit will be 1, so I will simply add that to my result. Now finally, when I get the value at the current position, I will simply do val cross val and sum it up with the final result, and this is finally will return as an answer. So hope this entire solution makes sense. If you have any doubts in any of the piece, feel free to follow up in the comment section below. I would be able to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already, and I will see you in the next one. Thank you.